Construct functions. When we construct functions, we're doing this so that we can then back engineer what the initial value was and the rate of change is for whatever real world situation that we're looking at. Remember with functions that we were using functions to find and then use patterns to model real world situations. Now we're going to get the data from the function and we're going to try to figure out what a couple things were. So what we're trying to figure out is, one, what was the initial value? And based on what we know about functions and linear equations, that initial value is the place where x equals 0, and then what was the output for that? What would y equal? And then we're looking for the rate of change. So we want to know what the rate of change was, And based on our working with linear equations too, we know the rate of change then is the slope. What is that slope? And then to do that, what we're also going to do is not just write those as values, we're also going to take those things and then interpret them. So be able to say, what do those things, we've run out of room. I'm going to put the dash here, interpret them. And then we'll figure out what those actually mean so that we can then decide what do the data mean after we see the data so we can make that function. So let's just look at this table real quick and see if we can figure this out. Let's use slope-intercept form. We're going to use slope-intercept form to determine what the initial value was. So where did that equation cross the y-axis? And then we're going to figure out what the slope is too. So let's figure the slope first. Just go back and use some slope formula. I've got an x sub 1, an x sub 2, a y sub 1, a y sub 2, which gives me 56 minus 53 over 2 minus 1, which gives me 3 over 1, and that's my slope. So my rate of change is 3. And then to figure out what the initial value is, let's use the rate of change and one of the points that we're given, and we'll use the point, the first one. That seems the least complicated. Let's use this point right here. That would be 1 comma 53. And to do that, we're just going to write out our slope-intercept form. Y equals mx plus b. B is what we're trying to figure out here. That's the initial value. And from that, let's just put these pieces in here. So that gives me 53 equals 3, my slope, times 1, my x value, plus b. Then that's going to be 53 equals 3 plus b, subtract 3, subtract 3. And now I've got 50 equals b. So now I know the initial value was 50. Initial value was 50. And I know that the rate of change was positive 3. That's great. Now what does that actually mean? Let's go back and look at the problem here. Dylan is planning to have his birthday party at a skating rink. The rink charges a party fee plus an additional charge for each guest. So a party fee is the thing that comes up first. So he had a $50 party fee plus $3 per guest. And you can kind of see that there, that $3 per guest then gives you the rate of change. So for each guest is $3 more. The initial $50 party fee, you only pay that once and then that's gone. All right, let's try another one here. Let's look at a problem where we only have words. And in that, we have Joan has some photos in her photo album. Each week she plans to add 12 photos. That sounds like a rate of change. So we've got a rate of change of 12. Not just 12, too. Let's remind ourselves that it's positive 12. She's going to increase it by 12 photos per week. Joan had 120 photos after 8 weeks. That sounds like an input and output. So if I had weeks and photos, I've got 1 point here. After 8 weeks, I've got 120 photos. So I set it up like that so we could see it as X and Y. So because we have a rate of change, we have a point, we can figure out where the initial value was here. So I've got then 120 is equal to the rate of change. times the number of weeks. So 12 photos times the number of weeks plus B. 8 times 12, so I got 120 equals 8 times 12. 8 times 2 is 16, carry the 1. 8 times 1 plus 1 is 96 plus B. So let's subtract 96. Subtract 96. And 424 equals B. That's great. We've got the two values we want. We've got a rate of change and we've got an initial value, but what do they mean? The rate of change is that she's going to add 12 photos per week. And what the initial value means, initial value, is that she started with 24 photos. So it begins with 24 photos, and then each week after that, she's adding 12 more. Our next example is with a graph. So with the graph, we're going to figure out the exact same thing. We're looking for initial value, and we're looking for rate of change. Here, we're giving a series of points, so let's use the points to our advantage here. We'll find slope with slope formula, so that's going to give us, let's see, we need an x sub 1, a y sub 1, an x sub 2, and a y sub 2. And our formula here is y sub 2 minus y sub 1, x sub 2 minus x sub 1, and we write these out. We've got 38 minus 32, and 6 minus 5, and that's going to give us 6 over 1. So that's our slope right there, our rate of change. We found that. Now let's figure out what the initial value was here. I've got y equals mx plus b. We know the slope. Let's get an input and output from the table. How about just that 5 and 32? That'll be pretty simple to use. So our output was 32, and that equals the slope times our input, which was 5, plus b. And that's 32 equals 30 plus b. And we get b equals 2. Subtract 30 from both sides. So we know the initial value, that y-intercept, where that graph is going to go through, where x is 0, so that's where the graph will go through the y-axis. But what does that actually mean? So the rate of change is 6. Let's go back and look at here. As a part of the grand opening, an arcade gave out free tokens to the first 100 customers. The graph shows the number of tokens people received for each dollar they spent. Find and interpret the rate of change. So the rate of change here is 6. And what that means is for every $6 they spent, for every $1 they spent, let's not forget here that this is tokens over dollars. There we go. So that is 6 tokens per dollar. And then the initial value is 2, which means what? That means they gave them 2 tokens to start. 2 free tokens. Great example of why labeling matters. If you keep track of your labels, you'll get to the end here and you'll have exactly what you want. I was not keeping track of my labels, especially when I figured out my rate of change. So when I didn't do that, I had to go back and think about it and remember, y over x, tokens over dollars. Keep track of those labels, otherwise when we get to this interpretation part, it's going to be difficult. Okay, let's see if there's one more here. No more! Let's just review. Okay, yay! Do you guys want to cheer? Yay!
Yay!
Yay! My kids are here, so they said yay too. They're tired of being quiet.
What? Sorry.
So we are constructing functions. So in constructing functions, let's not forget what we're doing here. We're taking the 3 versions of functions that we are aware of. We're taking a graph. We're taking a tablet. We're taking a words. And then being able to take those 3 things and construct an equation. And from that equation, we want to be able to interpret the initial value, which is b, or the y-intercept, or where the input x is 0. And we also want to figure out what the rate of change is, which is the slope, or m. And then that is the ratio of y to x, but then with the value, the qualitative values of those things. So you know exactly what's being compared. Okay, constructing functions. Good luck.